speaker is Chun Hsu Su, a senior research scientist at the Bureau of Meteorology, and will be presenting towards an even higher resolution reanalysis for understanding local climate, past, present, future.
Thank you. Good morning. Thanks for having me. Yeah, so I'll be asked here to talk about the Bureau's. Sorry.
We're not sharing the
No.
presentation, maybe? Sorry about that. Okay.
Yeah. Okay. So I've been asked to come here to talk about the Bureau's effort in developing the regional hemispheric reanalysis. So I'll touch a little bit about what we've done, what we're currently doing, and also what we think should be done to make advancements in this area. Okay, so I'll just start by giving you an introduction on what is a hemispheric reanalysis. So its job is to produce our best description of the hemisphere in the past by combining observations and models. So, and of course, the technique underpinning this is data simulations. Yeah, and the idea with the reanalysis, we want to do that by not changing the methods or the models or how we do this. And analyze as much observations to produce a long time series of the history. So just think to clarify, reanalysis is not observations, but it's really the next best thing where and when there isn't any observations. So by using models, therefore we can produce very high resolution information of the atmospheres over a large space and over a long time. So therefore the data is very useful for model evaluations, assessments, climate studies, various climatological products, and driving other models, and also potentially for machine learning where models requires atmosphere as predictors. So, and doing these studies over Australia, of course, we have global reanalysis, such as ERA5, MERA2, etc., produced by other major met centers. And also the Bureau produces a high resolution regional reanalysis called BARA. So BARA1 has been available since 2018. It's a 29-year deterministic reanalysis. It's made up of two systems. So the first system is BARA-R1, has a grid resolution of 12 kilometers. Essentially, it's developed based on the Bureau's experience in ACCESS-NRI. We use the unified model, the UM for the hemisphere and JULES for the land surface, and nested in ERA interim reanalysis. It uses a standard global hemisphere and land configurations, GAL6, but in the regional models. But we also make some local changes as we have learned from in developing the ACCESS-NRI. In the data simulation here, we'll simulate as much observations as possible as what you'll find in the NWP to keep drawing the model simulation to match the observations to therefore then give a accurate representation of the history. Then we have the second system, which is BARA-C2, and the development of that predates the standard regional hemisphere and land configurations, the RLs. That system is a downscaling, or just a dynamic downscaling of the BARA-R1 analysis. So in a way, BARA-1 is now almost old news, and there's increasing need to continue this reanalysis effort. And we're trying to do that with the second version of BARA-2. And this is being currently funded by and to support the new Australian Climate Service, ACS. So the BARA-2 also make up of two systems, BARA-R2, RE2, and the BARA-C2. So I'll talk a bit more about that in a minute, but just highlighting that we now the completed the development phase for BARA R2, RE2, and now has already entered the production phase. And we should be start producing, releasing the data for BARA 2 starting from next year. So in time, in 1-2 years time, we'll be looking at replacing BARA 1 in entirety. So just to emphasize that the BARA 2 is one of the key modeling pieces in the ACS, particularly to address the need for support service that requires a seamless view of the historical and future hazards under climate change. So here, just a case in point showing a heat wave. Wouldn't it be nice to be able to look at given a present day event and be able to look back at a long history of heat waves and see how to contextualize what's happening today compared to what happened before. And also as we look into projections, assessing the future risk. And of course, we all know that our projections have biases, and then the reanalysis can provide a reference to be able to calibrate and evaluate those projections. So here I'll just give you a bit details about the BARA 2. So you'll be going back to 1979, and the aim is to update it continually into the present day. So the first part of the system is the BARA R2, which essentially mirrors the BARA R1, 12 kilometers. We haven't changed the resolution here. But we have a few upgrades, which includes nesting in ERA 5 global reanalysis using almost the latest release GA7 science configurations plus some of the GA8 package changes to improve our rainfall. We also do have an offline land surface model juice runs to spin out the soil moisture. Because if we don't do that, the soil moisture will take years to spin up, to stabilize in our system. So spend quite a bit of effort to use new and reprocessed observations, in particular satellite retrieve winds, also soil moisture, and also reprocessed data such as radio sondes. And BARA RE2 is a new component added this time around. RE, the E represents the ensembles. So we have a 24 kilometers, 22 members leg ensembles. So it's there to help us capture some of the uncertainties from the driving models in the observations and also the models itself. And then, and the second component, the second system is the BARA C2. Here is deterministic due to funding constraints, but we'll be using the latest RL3 size, and the coverage of the system will be full national. So just a quick glimpse on a bit of the results. I don't want to go into too much details of this, but BARA 2 is different from BARA 1 and also different from ERA 5. So just to illustrate this, as well by Jupyter Notebook, plots a time series of the screen temperature at 2 locations, Avalon Airport and Canberra. That's after Googling for what might be how high is the hottest temperature in Melbourne in 2014 and Canberra in 2020. So here the BARA 2 ensembles is in gray, and then the BARA R2 deterministic is in blue. The other reanalysis is in other colors. So see, in this case, BARA better capture a higher temperature extremes in those days than observed in ERA 5. I mentioned about we try to use improvements introduced in GA8, particularly fountain buster and pronounced entrainments to improve rainfall. In BARA 1, we have issues with spurious excessive high rainfall. And also the tends to produce too much light rains at those resolution with the convection parameterizations. So that's improvements you can expect in BARA 2. Okay, I just want to spend a bit more time about how I see the future of BARA. Just want to highlight that data simulation is at the heart of high resolution reanalysis and also modelings. So there are many advancements can be made at this front. It's not necessarily just the game of the Bureau. So, we know that we need to assimilate more observations, and we need to do that better for kilometer scale reanalysis. We need to better use existing satellite data. We need to start exploring non-conventional observations, such as from, I think, your mobile phones can provide information that we can use. And also, of course, there are always new satellite missions providing new measurements of the atmosphere. And there's also questions of how to assimilate properly. And we're not, at this point, we may not even assimilate some of the channels on satellite in the best way as well. So there's a lot of open problems need to be solved. Also, to improve the model simulation for cloud and rainfall, we need to really get the moisture right. We can't expect the model to spin up put a cloud in the right place, producing a rainfall at the right place if the moisture is 100 kilometers away. We also feel that there could be collaboration with the machine learning, the big data communities to help with some of these problems. And one of them could be producing cheaper ensembles to allow us to move to the area of ensemble DA. We also want data simulations to help us capture the stochastic nature of the Earth systems and propagate uncertainties that we know in our observations, in our models. And eventually we really want to move towards a kilometer scale coupled regional reanalysis, and that will help us to bring to bear to solve a lot of problems about the water cycles, improving our hydrologies, our TC simulations, the vegetation changes. So that necessarily bring us to the field of coupled DA. So lots of many science problems. Okay, so and we can't do it alone. And so currently at the Bureau, the observing processing systems and data assimilation system is very difficult to use. I will not use them if I can help it. Which is why the Embed Office and the Bureau and we're joining with others, major centers are moving towards adopting this new framework called JEDI. So JEDI stands for Joint Effort for Data Assimilation Integrations. It's a unified frame infrastructure to do this. And it's engineered to allow collaboration with academic users to broader user groups. Comes with very modular, scalable design to plug and play. So also toy models to help beginners to get started and supports a range of platforms. And this is a schematic of trying to highlight that there's areas that are specific to different models, implementations, UMs, MON6, and that could be implemented. And I think UM and Alfred, a version of UM and Alfred is already part of JEDI. But just highlighting that there is a generic implementation of DA algorithms, generic libraries of data models, covariance modelings, observation operators that implemented that can to allow you to allow different users to interact with different models with different DA algorithms, and then using this idea called YAML files, configuration files to allow you to set this up, extract you from having to implement your own 4D bar or ensemble carbon filters, that sort of thing. Also highlighting there's also a coupled layer to allow exploring different couplings between DA, different models, and different ways of coupling too. All right, so lastly, so this is my last slide. So key message, BARA1 almost all news, BARA2 around the corners to support the ACS, BARA2 potential S values to BARA1 and ERA5. And we just feel that there's more science could be done in the data simulations to achieve the step change in the next BARA. Okay, I'll finish it there. Thank you.
One quick question.
It's working now. Thanks, Chun Hsu. The BARA data sets as they are now, right, there's more than one, are one of the most exciting things coming out of Australia and one of the most exciting things we could use for science. And yet the excitement of the research community is negative, if it's zero or negative for it. And I wonder what we can do about it, because this is really exciting stuff. And it's really a data set that we should all be using to do our various pieces of research when it comes to Australian climate. And yet we don't. Right, we still use ERA 5. And I wonder whether you had any ideas, and maybe the NRI, and this is what we're here for this week, can help in this way. What we can do, could we organize hackathons? Could we, what can we do to excite the Australian research community to use these actually really nice products? And what do we perhaps need to do on the technical side to make it easy for the community to do that?
Yes. Yeah, thank you. Thanks, Christian. Yeah, so of course, for a long time, the BARA one was in a limbo with the licensing, and that eventually sorted out. And then, of course, with the help of the NCI, now the data is also available, become on the thread server that make it easier to use. We also felt that in BARA 2, also want to improve how, not trying to put too much on the disk, but also make data a lot easier to so therefore we try working with the other parts of ACS to conform to certain data standards, particularly as the CMIT that the broader users are more familiar with, to make the data more accessible. And yeah, good point about the hackathons. Yeah, so user workshops, hackathon is probably something we should also think about if we want to get more users around that. Yeah.
However we do, it will make a difference.
Yeah, sure.
Thanks. Last question, Andy.
So one of the issues with BARA from a land surface perspective is you can't use the land surface quantities very easily for science because there's the data assimilation. ERA land solved that by doing a reanalysis of the land so it closed energy, water, and carbon cycles. That opened up the ERA data sets for the land surface community. Is there any thought within the Bureau to do a reanalysis that's conserving energy and water and carbon at the land surface in parallel with ERA land?
Yeah, so for ERA 5 land, yeah, so it wasn't, it's in my planning to consider having the BARA to drive a JULES, lessons models at a much higher resolutions that may address some of the issues, a bit similar to how ERA 5 land and MERA land is being developed. But currently there's no yet funding to support that. But there is also plans to consider having to actually do a proper land reanalysis as well. So my focus here is hemisphere, but there is not in my team, but there is there's a thinking led by Chris Rudiger and Andrew Frost in this space about doing a land reanalysis in coming years. Yeah.
Thank you. We need to move to the next speaker. We're running out of time. So